Hi there. Today we're going to be talking about making the most out of renewable energy sources. The world's demand for energy continues to increase, and that energy is currently delivered in the form of fossil fuels. The burning of fossil fuels, such as coal and oil, increases the concentration of CO2 in the atmosphere. And the science agrees that the Earth's climate is on a dangerous trajectory. The development of renewable or low-carbon energy sources allows us to meet our energy demands and make headway in tackling the issue of carbon emissions. This is a chart displaying the electrical demand and production for California on December 3, 2018. This data perfectly demonstrates the technical challenges that exist when renewable energy generation is part of the current existing grid. The plot shows the demand in red and the residual or remaining demand after renewable generation in blue. The load initially ramps up and peaks in the early morning hours when people turn on their appliances and have their morning showers. This all happens when solar is not producing, thus requiring the grid and utility companies to ramp up traditional energy supplies in just 3 hours. The overall load remains constant for the rest of the morning and early afternoon as people leave their homes and head to work. Solar generation starts coming online and forces the utility companies to ramp down their production just as quickly as they brought it online. The biggest peak appears in the evening when solar production ends and people return home and turn on their electronics. This requires a massive ramp up of generation in a short duration. The issue of supplying energy without over or under producing is a very difficult technical challenge, which is only getting increasingly more challenging as more solar generation capacity is installed. Batteries are one of the best ways to store energy produced by renewable resources. The downside to batteries is that they are very expensive to purchase for the quantity of energy that is stored in them. Tesla has battery banks that can be used at your home. A typical 1,200 square foot home with air conditioning and a charging electric vehicle. Tesla recommends 4 of their battery banks at a cost of $38,950 Canadian dollars. To help cut costs, rather than storing the energy in extra batteries purchased, the energy can be stored directly in your electric vehicle.
Electric vehicles contain a battery on board and is the main storage of energy, comparable to a fuel tank for an internal combustion engine. The downsides to purchasing an electric vehicle is that it needs to be constantly recharged. Generally, the majority of people would choose to charge their vehicle during the evening after they come home from work. This charging time adds to the peak demand of the system, which can cause even worse ramping problems for energy in the evening, which can be seen in the graph in orange. To counteract the extra ramping from charging in the evening, electric vehicles can be used to help flatten out the peak hours and bring up the lows that are seen during midday from solar energy by discharging and charging at certain times. The discharging of the vehicle battery is seen in green, and the charging of the vehicle is in orange, with the demand being the black line. How can this be done? Vehicle-to-grid technologies. Vehicle-to-grid technologies integrates a control unit between the electric vehicle and the house. The control unit can be used to communicate with the grid. During the usual peak hours, the grid can acquire energy from the fully charged electric vehicles to help drop peak demand times while not using harmful emission technologies. After peak hours begin to decline, the grid can then send energy back to the vehicles to fully charge them back up.
So what would a vehicle-to-grid system look like for a home? To find out, we ran a simulation in Homer, hybrid optimization of multiple energy resources. As inputs, we set up a typical suburban home in Los Angeles, California, with rooftop solar panels, a grid connection, and a battery, which simulates an electric or fuel cell-powered vehicle with vehicle-to-grid technology. The electrical load was synthesized with a total energy demand equal to the daily average California household. In this theoretical best-case scenario, we see that on a residential scale, the grid purchases can be eliminated entirely, which would aid in reducing the peak load problem as described earlier. All of the excess energy production by the solar panels can be sent off for industrial scale production of hydrogen fuel or to charge electric vehicles. To offset the peak evening load, the battery or fuel cell powered car provides energy to meet the demand, only requiring a small percentage of their overall stored energy.
This graph shows the distributed vehicle-to-grid market in 2016, where the compound annual growth rate for Europe's, the Middle East, and Africa was found to be 20.4%. Although currently it is not overly efficient for users to charge vehicles while not at home, the infrastructure is increasing rapidly, and vehicle-to-grid technology will be an efficient and easy way to reduce peak load times and allow for energy sources such as nuclear to become more competitive as the demand curve becomes more constant.